Okay, good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
In the previous lecture, we have completed particular solutions using shortcut method. I've also given you examples to identify yourself where you stand and how much you can do. Now we will start with variation of parameters. Variation of parameters. This is particularly for second order linear differential equation and degree 1. So second order linear differential equation of degree 1 looks like a into d2y by dx square plus b into dy by dx plus c into y is equal to capital X. And so this is a linear differential equation. So we can find out yc of course for this. Now we are talking about how to find the particular solution for this. So particular solution by variation of parameters looks like y variation of parameters yp is equal to u into y1 plus v into y2, where y1 and y2 are the solutions from yc. So to make ourselves clear what is y1 and y2, what we do is we look at this linear differential equation. So as you can see, the auxiliary equation for this will become a into d square plus b into d plus c equal to 0. So auxiliary equation for this, the auxiliary equation for this is this, and this is degree 2. So what we will have is the roots will be of the form both are real and distinct. Say if m1 comma m2 degree 2 has, you will have two roots. Then either you will have both of them as complex a plus ib, a minus ib. These are the only two cases. Since this is degree 2, you will have two roots always. Either both of them can be complex, I mean complex conjugates, or real and distinct, or real and repeated, m comma m. So what we will have, yc is equal to c1 e to the power m1x plus c2 e to the power m2x. Then yc will be, in the second case it will be c1 cos bx plus c2 sin bx e to the power ax. And the third one will be yc is equal to c1 plus c2x e to the power mx. So in the first, if I open the bracket for the second and third one, what I will have c1 e to the power ax cos bx plus c2 e to the power ax sin bx. In the third one, if I open the bracket, c1 e to the power mx, c2 in bracket x e to the power mx. So what I mean by m1 and m2 is this is sorry, y1 and y2 is to whatever functions c1 and c2 are associated, those are my y1s and y2s. In the first case, c1 with c1 you have e to the power m1x, so that will be y1. This will be y2. In the second case, this will be y1 and this will be y2. In the third case, this will be y1, this will be y2. So y1 and y2 are the things those are associated with c1 and c2 and yc. Okay, if you want, you can write it down. You have 2 minutes. Okay, now by variation of parameters, I have told you now your solutions look like u times y1 plus v times y2, where y1 and y2 comes from the auxiliary solution. Now, how to find out these u and v, where u and v are functions of x, where u comma v are functions of x. So we will find out the Wronskian first of all. W is called the Wronskian, and that will look like the determinant y1, y2, y1 dash, y2 dash. So y1 into y2 dash minus y2 into y1 dash. So this is how you take the determinant. So once we get the Wronskian, u will be given by minus integration y2 into x divided by Wronskian dx, and v will be given by integration y1 into x upon Wronskian into dx. So once we get this u and v, we will put that here, and that is our yp. So this is complete variation of parameter process to find out the solution or the particular solution for a given linear differential equation. We'll just recall what is x. What was x? Our differential equation looked like a d square plus b into d plus c y is equal to capital X. So once we have this, the right hand side is our f of x, or simply capital X, that you are placing it here. One more thing to note, to find out the coefficient, this u, you are multiplying it by y2, the opposite one, y2 into x by w. And for finding out v is the coefficient of y2, then you are multiplying by y1. Fine, now we will go for examples. Example 1. Solve by method of variation of parameters. The differential equation is d square minus 6d plus 9y is equal to e to the power 3x divided by x square. Auxiliary equation for this is simply d square minus 6d plus 9 is equal to 0. So the roots of this are, this is
3
simply
and 0.
d minus 3 square equal to 0. So d is equal to 3 comma 3. So yc will be equal to c1 e to the power 3x plus c2 x e to the power 3x. I have just opened the bracket. What I said, c1 plus c2x, whenever there are repeated root, we write it down in this manner. So I have opened the bracket to figure out y1 and y2. This is my y1, this is my y2. So by variation of parameters, variation of parameters, yp will be equal to u times e to the power 3x plus v times x into e to the power 3x. Now to find u and v is our task. So for u and v, we will find out the Wronskian. Wronskian is simply the determinant e to the power 3x, x into e to the power 3x. Then derivative of e to the power 3x is 3 e to the power 3x. Derivative of x e to the power 3x is x 3 e to the power 3x plus e to the power 3x bracket 1. So the answer is 1 plus x, 1 plus 3 plus x actually. Oh, sorry, not 3x. E to the, if I take e to the power 3x common, what I will have 3x plus 1 e to the power 3x.
Sir,
Oh, yes.
sir, can you repeat it once again? The
What?
Wronskian whole.
Wronskian, as I said in the previous slide, what is a Wronskian? Y1 you have to write down, then you write down y2, and in the second row you take the derivative of each of them. So y1 का derivative is y1 dash, y2 का derivative y2 dash, and then you are taking the determinant of it. So in this one, what I have done is My y1 is, what is my y1? Y1 is e to the power 3x. So e to the power 3x का derivative is this 3 e to the power 3x. And x into e to the power 3x. When you take the derivative of x into e to the power 3x, you have to apply u into v rule. What u into v rule says, first of all keep x as it is, take the derivative of e to the power 3x, that is 3 e to the power 3x, plus now you keep e to the power 3x as it is, derivative of x, which is 1. So now I will take e to the power 3x common from both of them. In bracket it is 3x plus 1. That's what I have written here. इसका डेरिवेटिव नीचे, ऊपर जो है इसका डेरिवेटिव यहाँ पे. I hope I have made myself clear. Is it clear now?
Yes, sir.
Yes,
Yeah.
sir.
Now take the determinant. How do you take the determinant? Do the cross multiplication. So e to the power 3x into e to the power 3x, that will be e to the power 6x into 3x plus 1, minus the other one will be 3x e to the power 6x. So I'll take e to the power 6x common, in bracket 3x plus 1 minus 3x. This two will get cancelled out. Answer is 1. 1 into e to the power 6x. So Wronskian is equal to e to the power 6x. Now we need to find u. I just write down the two formulas here. What is our u? U is equal to minus integration y2 into x divided by w. Y1 into x divided by w. So I'll use these two formulas over here now. So u is equal to minus integration. The formula y2. What is our y2? X into e to the power 3x multiplied by capital X. What is our capital X? The right hand side. What is our right hand side? E to the power 3x by x square. 3x divided by x square upon the Wronskian. What is our Wronskian? E to the power 6x dx. We have to integrate this now. This e to the power 3x into e to the power 3x will become 6x, and that will get cancelled out from the denominator. What we have, minus 1 of the x will get cancelled out, minus 1 by x dx. Can someone tell me what is integration 1 by x? Can anyone tell me what is integration 1 by x?
Log x.
No. Who said it?
Sorry, x plus c.
No, someone said it. Atharva, was it you?
Sir, 1 by
Yes,
log x.
yes, sir. Log X, sir.
Yes, Atharva is right. So integration of 1 by x is log x. So minus, being constant, can come outside. Integration of 1 by x is log x. This is the value of u. Now I will find out v. Now v is equal to integration y1. What is our y1 here? Y1 is equal to e to the power 3x. X is e to the power 3x divided by x square and totally divided by e to the power 6x. So e to the power 3x, e to the power 3x, e to the power 6x gets cancelled out, and we have integration 1 by x square dx. Now integration of 1 by x square.
Minus 1 upon x.
So this will be minus 1 upon x. So you can put the values at the place of u and v, and that will be our solution. And so yp is equal to minus log x e to the power 3x. Then v is minus 1 by x into e to the power 3x. So this x will get cancelled out. So we have yc and yp, both of them now. Hence the general solution is, or the complete solution is, so complete solution is y is equal to c1 e to the power 3x plus c2x e to the power 3x minus log x e to the power 3x minus e to the power 3x. This is our final solution. Clear?
Yes.
Next example. Solve by variation of parameter. Solve by variation of parameters, that is d square minus 2d plus 2. Y is equal to e to the power x tan x. What is our auxiliary equation? Auxiliary equation is d square minus 2d plus 2 equal to 0. We find out the roots. Those are
1 plus I, 1 minus I.
1 plus minus I. So yc is equal to c1 cos x plus c2 sin x e to the power x. So I will open the bracket and declare my y1 and y2. So that will be c1 e to the power x cos x plus c2 e to the power x sin x. This is my y1, this is my y2. So by variation of parameters, yp is equal to u times e to the power x cos x plus v times e to the power x sin x. So you have y1 and y2. So we'll find out Wronskian Wronskian is e to the power x cos x, the y1, e to the power x sin x. In the below line, I have to write down the derivative of e to the power x cos x. So I'll find out the derivative on the other side. E to the power x as it is, derivative of cos x is minus sin x, plus cos x as it is, derivative of e to the power x is e to the power x. So the derivative here is e to the power x in bracket cos x minus sin x. Now the derivative of e to the power x sin x, e to the power x as it is, sin x का derivative cos x, plus sin x as it is, e to the power x का derivative e to the power x. So here I will have e to the power x in bracket cos x plus sin x. So let's find out the determinant of this now. So we'll have e to the power 2x in bracket cos square x plus cos x sin x minus e to the power 2x in bracket sin x cos x minus sin square x. You take e to the power 2x common. In bracket cos x sin x will get cancelled out from both of them, and cos sin square x cos square x will become 1. So Wronskian is equal to e to the power 2x. Now u is equal to minus integral y2. What is our y2? E to the power x sin x. What is our right hand side? Our right hand side is e to the power x tan x upon the Wronskian, which is e to the power 2x dx. So e to the power x into e to the power x will get cancelled out from the denominator. I can write this tan x as sin x upon cos x. So what we will have here is sin square x upon cos x tan x. So sin square x I can write it down as 1 minus cos square x upon cos x dx. You separate the denominator, 1 upon cos x becomes sec x minus then you take the minus sign inside, cos x minus sec x dx. So u is equal to integration of cos x sin x minus integration of sec x is
Log of sec x plus tan x.
log of sec x plus tan x. This is your u. V is equal to integration y1 is e to the power x cos x into the right hand side is e to the power x tan x upon the Wronskian, which is e to the power 2x dx. These will get cancelled out. Tan x is sin x upon cos x. Integration of sin x so
Minus cos x.
minus cos x. So we have u, we have v. Just put that and we'll get the solution. So yp is equal to sin x minus log of sec x plus tan x bracket complete cos x e to the power x, and the other one will be v into y2. The value of v is minus cos x into sin x e to the power x. The other one will be minus cos x into sin x e to the power x. The final solution y is equal to yc plus yp, that you can write it down on your own. Next example, this is for you. You will have to solve it. You will have 10 minutes for this. Solve by variation of parameters. d2y by dx square plus y is equal to cosec x.